Good afternoon, everybody. Welcome to Mathematics IGCSE, and this is exercise 5.15. It's the last exercise of section 5, and you shouldn't have too much problem with this. It's just estimation, and we have to learn how to estimate so that we can check to see whether our answer is correct or not. So exercise question 1 and question 2. Question 2 asks you, okay, well, let's start off first with question 1. I'm going to do question 5.15, and I'm going to do question 1b as an example. 1b is 4.82 plus, multiplied by 6.01 divided by 2.54 plus 1.09. So the way to estimate is to change all of these, reduce these significant figures. These are all written in 3 significant figures. So we want to reduce them to 1. And if we want to make it, the thing with estimation, it must be quick and easy. Because you want to save time, you just want to take a good guess. So we're going to change these all to 1 significant figure. So 4.82 becomes 5. And 6.01 becomes 6. 2.54 can become 3. And plus 1.09 becomes 1. This is equal to 5 times 6, which is 30, over 3 plus 1 is 4. Now you can divide 4 into 30. That's easy enough. 4 goes into 30 7 times. 7 4 is 28, and there's 2 over. So we expect this answer to be somewhere around 7.5. Now let's check it on the calculator. I suggest you do question 1 and question 2 together. So once you've estimated 1, check it immediately on the calculator. See whether you're close, how close you are. Whether it's close enough, see whether you need to do it a different way to perhaps improve your accuracy. But most of the time you shouldn't have a problem. So we've got 4.82 multiplied by 6.01, and this is divided by 2.54 plus 1.09, and the answer is 7.98. 7.98. So I would say that is close enough. If you get at least the same digit here, that's okay. The only thing we might have done is maybe keep this at 2.5, but that's not the method that they're recommending, because we would then have 5 times 6 over 2.5 plus 1 would be 2.6, and that's going to defeat the purpose. Okay, so that's as good as that one gets. It's just to make sure that you haven't made any gross errors. Number 1J, we have a square root like this, and under the square root is 223.8 multiplied by 45.1, and so what we've got to do here is we've got to reduce this to 1 significant figure each. So it's going to be 200, okay, multiplied by 50. And 200 multiplied by 50 is 5 to the 10, 10,000. And what is the square root of 10,000? We can say 10,000 is 100 times 100. And that means that this is the square root of 100 times the square root of 100. So that is 10 times 10. So the answer is approximately 100. Okay, let's see what the actual answer is. Square root 223.8 times 45.1 is 100.47. So 100.47. That's pretty close. Okay. Sometimes you're quite close, sometimes you're not that close. So that's why I recommend check your answers. And if you're not happy with them, if you think they're a bit too far out, see if you can make some adjustments. 1L. Okay. I better make this look more like an L. This is 4.1 cubed multiplied by 1.9 to the power of 4. So 4.1, this is 4 cubed. 4 cubed, we don't actually need the brackets anymore because the decimal has gone. So it's 4 cubed multiplied by 2 to the power of 4. 4 cubed, 4 4 is a 16, and 16 times 4 is 64, and 64. And 2 to the power of 4, we all know is 16. So 64 times 16, now we can reduce these again to make it simpler. So we can say this is 6 times 16. Okay, if you know your 6 times table, 16 times table, otherwise to multiply just a single digit by this is quite easy. Yeah, because 6 6s are 36, carry 3, 6 1s are 6, it's 96. 6 16s are 96. The more you do this by hand, the better you become at learning your 13 times table, your 16 times table, and so on. Let's see what this is. It is 4.1 to the power of 3 multiplied by 1.9 to the power of 4. And let's just watch out that you don't. Once you put in the power of 3, you have to get out of that power mode before you put your times in. And 1.9 to the power of 4. And the answer there is 898. 898.19. 898.19. So, that is the problem. This should have been 60, not 64. Okay? So there would be another 0 here. So this would be our estimate, and that's the actual value. So the actual value is approximately 900, but we estimate 960. So even this is good enough, because so you know if you get an answer of 10 or 3 or 0.2, it's wrong. So it's got to be in that range. That's what this estimation is all about. It's just to quickly look and see whether the answer that you've got is possibly right. Okay. Well, that is the end of exercise 5.15 for this section, and that's the end of section 5. So